Dante, Alicia, Olivia, Joseph, Stephanie, Castro, Kiki, Malachi, Jalen, Gabby, and Adrian. Okay, great. So you've got pretty good attendance today. Thank you all for being here. Welcome to another week. Today is November 16th, 2020. The topic for today's lesson is pathogens. It is the 5th day of our 8th unit. And I also want to just take some time, as I do at the beginning of the week, to remind you all to be present in this lesson, to be present in your work for the week, to think about some goals that you'd like to achieve by the end of the week, write them down, record them, maybe even share them with the people to whom you're close. And then as you think about them, start to develop a plan. Start to develop a plan about how you can achieve those goals. Now that you've put them into your head, now that you have this idea of what you're hoping to achieve, I believe in the power of positive thought. So if you start to think that you can achieve those goals, if you start to see yourself at the end of the week having achieved those goals, you'll be in a much better place to achieve them. You're going to start subconsciously moving towards them. But of course, you've got to pair that positive thinking with some positive work, some hard work as well. It's not just a matter of being wishful in your thinking. It's not just a matter of having some dream or some fantasy come true. You've actually got to set yourself up to be in a position to achieve those goals. So at the beginning of every week, it's a good idea to just try to center yourself, to take some time to think about what you're hoping to achieve this week. Try to write it down, start to develop a plan, but really be positive in your thinking about it. Believe that you can achieve it, and that'll really go a long way. Okay, but as it relates to today's lesson, I hope you all already have your notes out and you've written down the title of today's lesson, as well as the date. But the objective for today is biologists will be able to explain how various disease agents, such as viruses, bacteria, chemicals, etc., can influence natural selection. Our essential question: how do viruses compare to bacteria? So we've talked last week about natural selection. We talked about evolution. Now we're going to introduce how this concept of how pathogens can play a role in that process, in those processes. All right. So a pathogen is defined as any foreign substance that can cause a sickness or a disease. And pathogens might have antigens on their surface. And those antigens induce or cause an immune response. So again, what you see highlighted is what you should be writing down. A pathogen is any foreign substance that can cause a sickness or disease. Some pathogens have antigens on their surface, and those antigens will trigger some type of immune response in the host. So they'll tell the host, hey, I'm not supposed to be here. The host picks up on this. Sometimes the host has the defenses that will allow it to eliminate the pathogen. Unfortunately, there are times when those defenses don't exist. They haven't been made yet. Thank you for joining us, Omari. So what we're seeing on the left is a specific type of virus. This is called a bacteriophage. And these bacteriophages are attaching themselves to the surface of some type of bacteria. and they're going to hijack that bacteria. They're going to insert their DNA, and the bacteria will essentially serve as a reproductive mill for the virus. It's just going to start producing more and more viruses. So viruses are pretty, they're the real deal. They can be pretty heinous. So you guys probably already have some knowledge about genetic diseases versus infectious diseases. So what do you know about genetic diseases? We've talked about these before.
Well, we already know that genetic diseases passes through genetics.
They do what?
Genetic diseases, they pass through the genetics, which means anyone
Okay.
can get it.
Okay, so maybe we can say that these are inherited diseases. As you say, they're passed through genetics. So yes, they are inherited from your parents. What else can we say about them? Where do they come from? Well, I guess I already answered that. You inherit them from your parents. Let's see. So they can also come as a result of mutations as well. And we know that a mutation is some type of unintended change in an individual's DNA sequence. We know that a mutation can be caused by radiation. Some mutations just kind of happen randomly. Mutations can happen as a result of older age. But genetic diseases are, for example, cystic fibrosis, which you guys researched, Down syndrome, or sickle cell anemia. Those are all, and there, of course, there are many hundreds of genetic diseases. But if you're interested in that, perhaps you should take another class on genetics when you get to college. What do we know about infectious diseases? And of course, you all don't need to, you should write down the infectious diseases box, but you don't need to write down the genetic diseases box. What do you already know about infectious diseases?
Infectious diseases are disorders caused by organisms like bacteria, viruses, fungi, and parasites.
Good. That was a really comprehensive definition. Thank you, Justin. So they're caused by pathogens. What else? Why do we call them infectious? Where do they come from?
An outside source?
Some outside source, yeah. We could specify, depending on the type of pathogen it is, but they're not a result of any change in our DNA, in our body's DNA. They're coming from somewhere else. So we'll talk about some additional examples today, but COVID-19 is an infectious disease. The common cold is an infectious disease. Hepatitis is an infectious disease. And we'll talk about some others. Sorry, I do want you to make sure you write this down. Okay. So the first type of pathogen that we'll discuss is bacteria. Of course, bacteria is a plural word. So if you're trying to say a singular one of these, then you'd have to say a bacterium. Keep in mind that most of these words are Latin in their origin. And so adding an A or an AE or an IA to the end of something makes it plural. Something that ends in UM is typically singular. But bacteria are omnipresent, living, unicellular, prokaryotic microorganisms. Some bacteria can cause diseases, and some of those disease-causing bacteria can be killed with antibiotics. Now let's break this down. What does the word omnipresent mean? This is a great word to know. Omnipresent. Any ideas?
I hear you said what?
What does the word omnipresent mean? I'll give you a hint. The prefix omni, and I'm sending this to the chat, means all or every. So what does omnipresent mean?
Oh, I remember it. It means
Like a widespread spread, I mean.
like common or widespread.
Yes, Joseph, that's good. What did you say, Castro?
I said widespread.
Good. Widespread is a good way of putting it too. Omnipresent just means something that is present everywhere. You can find it in any number of places. So bacteria are found basically everywhere. And the thing about bacteria that's pretty unique is that they are living. So they do not necessarily rely on a host. So bacteria can exist in aqueous environments. They can exist in water by themselves. They don't necessarily need to live inside of a host. They are unicellular, and they are prokaryotic. Of course, we know what the word prokaryotic means, but I included this image so that you all would have somewhat of a reminder. Prokaryotic organisms do not have nuclei. As we can see, this thing does not have any nucleus. Prokaryotic organisms also have a cell wall. They have ribosomes, but their DNA, again, it's not located inside of a nucleus. It basically just floats around inside of the cell. Now, we've got some different types of bacteria over here on the left. Does anybody know think they know what these bacteria cause, what diseases these bacteria cause?
No, I don't think so.
What's that?
I'm not sure. I don't think so.
Okay. I do want to point out one thing to you all. We should notice something here, and that's that these are the scientific names of these bacteria. How do I know they are the scientific names? Because I've got two words for each. The first word is capitalized, and both of the words are italicized. So this first word, for example, Streptococcus, is the genus of this bacteria, Streptococcus. And then pneumoniae is the species name. So this is the bacteria that causes pneumonia. We've got Clostridium tetani. This causes tetanus. And many of you probably, you've heard people say, I need to get a tetanus shot. Sometimes if you are bitten by a specific insect or rat, or you accidentally step on a rusty nail, you should go get a tetanus shot because this bacteria might be residing on the surface of that nail or in the mouth of the animal that bit you. What else? We've got Vibrio cholerae. This causes cholera, which is, of course, a very, very deadly disease that thrives in damp, moist, warm environments. Many, many people in the continent of Africa and in South Asian countries die every year because of cholera. Cholera typically is a result of what am I trying to say? Dirty drinking water. People who are drinking water that has also been contaminated by typically fecal matter. So in places where they don't have sophisticated sewer systems, you know, you and I, we can just flush our toilets, and we know that that flush is not going to ever, it's not ever going to contaminate our drinking water. But in some places, obviously, they are still using outhouses, or they, you know, they have these community bathrooms that are just not really very sophisticated. Their drinking water can eventually be contaminated by that fecal matter, leading to this, and that's where this bacteria thrives. So, of course, when the humans then drink that water, they can end up with cholera, which causes extreme dehydration, diarrhea, and eventually death. Salmonella typhi, this causes salmonella. Perhaps you've heard people say that some types of foods have to be recalled because they are found to carry salmonella. Again, that can also cause really severe muscle cramps. It can cause severe stomach pains. It can cause nausea and diarrhea. So pretty serious diseases here caused by these microorganisms that, you know, you couldn't even see with your naked eye. You'd have to use a pretty sophisticated microscope to see them. This causes Legionnaire's disease, which is basically a different type of pneumonia. This disease comes from rat bites, so not good, not good. This is the staph infection. People who are in dirty locker rooms might end up, if they have an open wound, might end up with a staph infection. So I'm sorry if I'm grossing you out. Okay, but nothing to write down here, but I wanted to point this out to you all. Each of us has our own microbiome, and we are unique in our microbiome. So we have bacteria, a lot of bacteria that live in and on us all the time. Most of these bacteria are totally harmless, but there are also some of them that are actually beneficial to us because they help to fortify our immune system, and they also assist with digestion. Now, when I say a lot, what I mean is that there are actually more bacteria inside and on you than there are cells in your body. Okay, so these microbes are really, really thriving all over you. Now, as science progresses and advances, we might someday be able to identify a person based on their microbiome. So, for example, if the authorities were to find a corpse somewhere, and they were able to analyze that person's microbiome, they might be able to determine where that person's from, what types of foods that person ate, what was in their drinking water, and all of those things can give you a good idea of who that person is if you don't have any other way of identifying them. Some other types of bacterial infections or bacterial diseases. Necrotizing fasciitis is a disease that is essentially tissue death. So it's caused by a bacteria that essentially shuts off the blood supply to different parts of your body very, very rapidly, causing pretty extreme bruising, and eventually the tissue just dies. And this happens very, very quickly. It's a very dangerous disease. In fact, it often will lead to amputations. Strep throat, some of you maybe have had strep throat in the past and you've gotten your tonsils removed. This is a very severe case of it. This person's probably in some pretty bad pain. A staph infection, gonorrhea, and syphilis. Both gonorrhea and syphilis are sexually transmitted. So we don't have a sex ed class at West Mac. I don't know if you all take or talk about sex ed in your physical education classes, but I did want to mention to you all that this is an important reason to practice safe sex.
Are those STDs?
What'd you say?
Are those STDs?
Yes, these are STDs, sexually transmitted diseases, or STIs, sexually transmitted infections. And this means that these bacteria, these two specific bacteria, are transmitted via sperm and via vaginal juices. So these can, during sex, these can eventually be transmitted to another person. This is why it's important to practice safe sex. Like I said, I don't know if there's any sex ed component of your gym classes or your physical education classes, but it's important for you all to know that, the most effective safe sex program is not one that preaches abstinence, right? So, some people choose to have sex at earlier ages than others, and in certain circumstances that are different than others. That's okay, but it's not okay to not do it safely. It's also important that you all have open conversations with someone in your life who can walk you through some of these difficult questions, because you need to learn a little bit before you become sexually engaged. You need to know what your options are. You need to know how to protect yourself, and you need to know how to get tested. And getting tested is not a bad thing. In fact, it's a good thing. It's something that everyone should be doing if they are sexually active. You should know anytime you have a sexual partner what that person's history is. You should know what you're exposing yourself to, and you should be honest with them about things that what your experiences have been. So getting tested is an important part of that, to know what your status is, to know that you are healthy. And that's something that maybe you all don't talk about in your other classes, but obviously this is a science class, so we can come at it from that perspective. These diseases are very, very dangerous. Gonorrhea is one that you can get rid of, but it's also just kind of, it's not fun to have. And syphilis is much more serious, as you can see. So just wanted to bring that up. Now, the other type of pathogen that we discuss is viruses. Viruses are small, non-living structures that use a host to reproduce. Viruses inject their genetic material into the host and essentially hijack the host. Some viruses can be neutralized by antibodies and by antivirals. Not all viruses, though. There are some viruses that continue to exist for which we simply don't have an antibody. We don't have any way of treating them. For example, HIV. We have no way, we can treat HIV, but we don't have a cure for it. We don't have any antibody that can prevent it. Okay. So here's how viruses work. Now, what we're seeing here is a bacteriophage, and we can also see a real microscopic image of them. But these viruses have a protein coating. The protein coating works kind of like a cell wall would work. And inside of that protein coating is some type of genetic material. The viruses will inject that genetic material, which we can see here looks kind of like a worm. It's being injected into the bacteria, and then the bacteria gets hijacked. So instead of the bacteria doing what they already would be doing, whatever normal activities they are engaged in, the genetic material from the virus is injected, and now that genetic material tells the bacteria, your only job now is to make more virus. And so the bacteria will dedicate all of its organic material, all of its proteins, all of its amino acids, all of its carbohydrates, and all of its lipids to making more of that virus's genetic material. And so this is why viruses can be so dangerous. So some examples of them include herpes, the common cold, influenza, which is the flu, HIV, and the human papillomavirus. The coronavirus, which we'll talk more about today, is also a type of virus. So herpes, HIV, HPV, these are all STDs, and there's no cure for these STDs. So in addition to those three, like I said, we also talk about hepatitis. Those are we call them like the 4 H's. So those 4 STDs, herpes, HIV, HPV, and hepatitis, we call them the 4 H's obviously because they all start with H, but they're all transmitted by viruses and none of them can be cured. So if you get them, you're going to have them for life. It doesn't mean that you will, it doesn't necessarily mean that you die right away. Even with HIV, people with HIV in the year 2020 can go on to live pretty long, healthy lives. In fact, we have treatments now that can get people to a point where their HIV is not even detectable anymore. But it is important to know that if you do end up with these viruses, then you will have them for your life. The common cold and the flu, for example, our bodies have gotten good at producing antivirals that can induce an immune response. For whatever reason, with these other more complex viruses, we don't end up seeing that same immune response. In fact, HIV is called the human immunodeficiency virus because it prevents your immune system from working properly. Not only does it prevent your immune system from attacking that specific virus, but it will also prevent your immune system from attacking many other types of viruses, such that even something as simple as the common cold can linger for weeks at a time. And that's why HIV is so dangerous. So again, important that you all are having conversations with people who you trust and people who you care about your sexual health as you get older and as that becomes more a part of your life or of your lives. It's important that you know what your options are. Of course, no one should be forcing you to have sex, but when you do make that choice for yourself, you should be careful about how you do it. You should be selective about who you do it with, and you should be respectful of both yourself and your partner to the point where you're willing to protect yourself, willing to get tested, willing to know your status, and willing to talk about it openly with your partner, that is.
I have a question.
Yes.
So these, I call them STDs. Are you supposed to let people know that you have them? Like, if you don't, is that illegal?
Well, you should certainly know. You should certainly let your partner know. Your whoever you are engaged with sexually, you should let them know what your status is, regardless of what the STD is. So even if we think about gonorrhea, which of course can be cured, you should still tell people who, the person you are having sex with, that you have gonorrhea. But in the case of HIV, it actually is illegal in some places to withhold that information from your partner. So if you have sex with someone, you don't tell them that you have HIV, and then they later find out, they can actually press criminal charges against you for that, because HIV is so deadly and so dangerous. Okay. So let's briefly talk more about COVID-19. We only have a few more slides, and then you all have ample time to work on the asynchronous assignment for the day. Excuse me. So COVID-19. COVID-19 is caused by what we call the novel coronavirus. And it is just one particular type of within a strain of viruses called the coronaviruses. We get this word coronavirus because this class of viruses has these spikes on the outside that they remind you of the spikes from the sun, or they might remind you of the spikes from a crown. And so the word corona is Latin for crown. But coronaviruses are quite common. So the novel coronavirus, the one that is causing COVID-19, is just one of those coronaviruses. But there are many others that are much more common and much less severe. They typically just cause common cold symptoms. So the official name of the novel coronavirus is SARS-CoV-2. That CoV should be capitalized. The V should be capitalized. And it's this virus, that SARS-CoV-2 virus, is very similar to the virus that caused the SARS outbreak in the early 2000s. You all probably weren't even alive yet, but SARS was a major outbreak that scared many people around the world, but it didn't end up actually killing many people. It didn't infect that many people, but it stands for severe acute respiratory syndrome. Severe because obviously it's dangerous. Acute because if you survive it, it won't last forever. Acute is kind of the opposite of chronic. And then respiratory syndrome because it affects your breathing. So this novel coronavirus, or the coronavirus disease of 2019, which is what COVID-19 is, coronavirus disease of 2019, it attacks the lungs, which can lead to pneumonia. And pneumonia is an inflammation of the lungs, which can lead to an accumulation of fluid buildup. Now, for vast majority of people who are infected with the novel coronavirus, they may have symptoms that last a few days. Some people end up asymptomatic, which means that they will be infected with the virus, but they don't end up displaying any symptoms. And then there are few people who end up with quite a severe and potentially deadly case of COVID-19. As we know, in the United States, cases continue to rise. Just this past Saturday, we saw about 170,000 people in one day test positive for the coronavirus, and that set a new record. But even almost every day for the last week, we've set new records for positive cases. And so even though, we're hearing a lot about opening up the economy or going back to school or, allowing people to return to normal, unfortunately, we have not controlled the spread of the disease. And so by most accounts, returning to normal or opening up the economy could be quite dangerous, because we would then see even more spread than we are seeing now. But it's a balancing game, because if the economy is not open, quote unquote, that means that some people won't be able to work. And we know that at the beginning of this pandemic in March, we saw the economy tank to levels that it had not tanked to in 30 years, 40 years since the 80s. So, it's a balancing game. You don't want people to suffer because they can't work and can't make money, but you also don't want people to suffer because they are stricken by this deadly disease. So it's a difficult policy case, and it's really one of the primary reasons why Donald Trump lost the presidency, because he did not handle this well. All right. Now, antibodies are proteins, and we've learned that a couple times in class. But antibodies are meant to recognize foreign substances that invade our bodies, and they can essentially attack that foreign substance and destroy it. The problem is that every virus has a different antigen. Every pathogen has a different antigen, as we talked about in the beginning of the lesson. Look here. Every pathogen has a different antigen on the outside. And so our bodies need to be able to produce antibodies that can recognize these antigens. But as is the case with COVID-19, with the novel coronavirus, our bodies don't always have the abilities to recognize that antigen. And so until that happens, until our bodies do gain that ability, either because you get infected and you survive, or you get these antibodies via a vaccine, then unfortunately we will still be subject to infection. And you may have heard at the beginning of the pandemic that people could not get COVID-19 twice. We now know that that's not true because the novel coronavirus has mutated. So people who maybe got it in March or April or June are now no longer immune to it because the virus has mutated, and so our bodies are not able to recognize it in the same way. So it's an interesting scientific development, and this is why it's important that we have we develop some type of vaccine. We know that 2 companies now have developed vaccines that are more than 90% effective, which means that more likely than not, the Federal Drug Administration, the FDA, will provide them with emergency authorization to begin producing these vaccines in large numbers. So we could see people as early as December or January getting this vaccine. Now, in the beginning, it's not going to be available to people like you and I, but it might be available to our grandparents, or if you have parents who are nurses or doctors, they might be able to get it, because we want people who are on the front lines who are going to be exposed to this virus, or people who might experience a more severe case of the virus to get the vaccine first. And so we anticipate. What's that, Ayana?
I was gonna say, what if you have health conditions like asthma and everything else?
Yeah, then you might be eligible, depending on how much is available. I think what I've last read is that about 20 million people will be eligible to be on that first, to get the vaccine first. And most of that, again, will go to people on the front lines, the doctors, the nurses, the emergency medical technicians who work in ambulances. Those people will get it first so that they can continue to work. That way, what's happening now is that nurses and doctors all around the country are getting the virus. They're being infected, and so now they are no longer able to work. That puts a big strain on our medical care and our hospital care systems, because we just simply aren't, some hospitals are literally running out of personnel. They don't have enough nurses to cover all their shifts. So we need those people to be vaccinated as quickly as possible so that they can continue to treat the people who do end up getting sick. And then after that, it'll be people with pre-existing conditions and older people. And then after that, it'll be the general public. So it might be, it might be some time until people like you and I who may not have pre-existing conditions get that opportunity. It may not be until March or April, but we are on our way. So Pfizer is a company that last week released results from their studies showing that their vaccine is about 90% effective. And then another company today, Merck, just came out saying that they have results that show that their vaccine is about 94.5% effective. So this is a good thing. We do want multiple companies to have, multiple vaccines. That way we can produce more. But now it's a matter of the FDA looking at the results of these trials. And that's going to take about 2 weeks because those results are probably about 100,000 pages long. So in order to pour through all of that, in order to see the specific science behind the vaccine, in order to make sure that the experiments were done well, that's going to take a long time. But once that happens, these companies should receive emergency authorization to start producing their vaccines. And we'll start to see people receiving the vaccine maybe as early as Christmas. So we'll see. Okay. All right, so toxins are another type of pathogen. A toxin is a poisonous substance, typically that can come from another organism, spiders, snakes, some marine life like jellyfish or eels. Some frogs and toads have coatings on their skin that are poisonous. And then parasites. Parasites are organisms that live inside of a host, like a tapeworm or malaria, and that's how they get transmitted from one host to the next. So malaria, for example, it's carried by mosquitoes, and if the mosquito bites another person, that person can end up getting malaria. Malaria is a huge problem in Western Africa because they have, pretty high mosquito populations, and it can cause kidney issues if left untreated. All right, let's watch this. Quick, nasty videos. All right, so you saw that the venom from that snake coagulated the blood. It caused the blood to no longer be liquid. It solidified it, which of course, if that happened inside of your body, would be a huge problem. It could cause stroke. It could cause heart attacks. It would be extremely painful. And so not a good thing.
So here before us, Askari Zumbrikoidis.
Wow.
The largest station Dr. Nyashira has ever seen.
In Southern Sahara.
She will never eat spaghetti ever again.
My. Spaghetti. Wow.
But Dr. Nyashira is about to vomit.
Wow.
Dr. Maina, you really missed out.
What is this? My.
Come on here.
My.
Wow.
My goodness.
Huh?
What? Hey, my goodness.
Bigger ones, some are the mother, some are the children.
As carries limitated. Hey, is that a snake?
Okay, so that's some type of parasite. It looks like a tapeworm that exists inside of someone's intestines. Of course, parasites they also need to eat, so they essentially live inside of the host to eat the host's food. So in this case, this person probably was experiencing nausea, diarrhea, but they also probably were not able to take in any food or water because this intestinal parasite, those tapeworms, were eating all of their food and drinking the water, which can also lead to severe kidney issues. So not good, not good, and pretty nasty as well. Okay, so we'll play this quick Kahoot. Actually, I don't really want to play the Kahoot. It's a Unit 8 review, so we'll have time to play that tomorrow. What I do want you all to do is jump right into the asynchronous assignment, which I am going to post shortly. Okay, the assignment is there for you all. It's called pathogen practice.
Mr. Red,
Yes.
if bacteria doesn't need to go inside the body to live, why do they go in there anyway?
That's a good question. I mean, it's not like they are making an active choice to enter a host, but they do benefit from a host. The many bacteria thrive in specific types of environments that are present inside of hosts. For example, many of them thrive in warmer environments and aqueous environments, and our bodies provide that because we maintain an internal temperature of about 98.6. Which is ideal for a lot of bacteria. And we also are 70% water, which is also ideal for a lot of bacteria. So it's not that they're making the active choice to, and they can thrive in, for example, a lake or in a river. They can live there too, and feed on the organic material that's present there. But they can also thrive inside of a human or inside of an animal. And really just the same ways, but they obviously have deleterious effects on our bodies when they are inside of us. So again, it's not really an active choice, but it works for them.
Okay, thank you.
You're welcome. Okay, it is 11:36. So with that, you all are good to go. Tomorrow is our last day. We're going to do some review in anticipation of our test Wednesday. You have about 60 hours to complete all of the assignments from this unit, including the warm-ups and the asynchronous assignments. So please make sure you're doing that. If you need some help doing that, or if you need some leniency, please reach out, but I don't know unless you reach out to me. All right, so I'll talk to you all tomorrow. I hope you have a good Monday.